From the University of Tokyo, I'm chairing this afternoon session. We have first 4 presentations in this session. So let me remind you some important notices for your presentation. Each speaker has 20 minutes, including discussions. The presentation itself have but 15 minutes, then 5 minutes discussion. So, okay, time is coming. The first speaker is Miss Saran Choi from the McCune Pong National University. Well, please start your presentation when you are ready.
Good afternoon. I'm Sarang Choi, the master student from Gyeongbok National University in Korea. Thank you for giving me a chance to present at Pan-Pacific Conference. Today, I will talk about effect of leading operating parameter on fibrillation of organosul pulp. Content of presentation is as follows. Synthetic polymers are used for various purposes due to excellent strength and low prices. However, due to the environmental pollution, we need green material which can replace oil-based polymer. Cellulose is an eco-friendly resource which is abundant in nature. So cellulose attracts attention as a substitute for oil-based material. Recently, research has been actively carried out on CNF or MFC, which has made cellulose in nano or micro scale. Based on the outstanding properties of nanocellulose, we try to use them as a reinforcement or additive in various fields. There are applications to name a few, such as filters and packaging material, solar cell component, and composite material, food and medical material, and so on. Typically, CNF is manufactured by lignin-free cellulose at a concentration of less than 3% in homogenizer or fluidizer. However, this method limits commercialization of CNF because of low production yield and the high energy consuming associated with mechanical fibrillation of cellulose fibers. Lignin-rich cellulose could be an alternative to bleached cellulose. Lignin-rich cellulose with high lignin content has both advantage of hydrophobic lignin and hydrophilic cellulose. Therefore, lignin-rich cellulose provides an improved production yield of nanocellulose. And it gives more potential in various applications compared to the bleached pulp, although it might be weaker than bleached cellulose. So we tried to make fibrillation in a simple method using lignin-rich cellulose. In this study, we tried to produce fibrillated fibers through an alkali kneading treatment. In addition, the effect of pulp concentration and kneading time on fibrillation properties was analyzed. In this study, Radiata wood chips with lignin content of 28.7% were used as raw materials. The size of matchstick chips were used for organosul pulping. Also, glycerol and sulfuric acid was used as a reaction agent. This slide is about experimental method. For making organosul pulp as a raw material, the wood chip and solvent were reacted for 2 hours at 120 degrees Celsius in autoclave. After the reaction, we washed lignin and solvent with water to reach neutral pH. The yield of unbleached organocell pulp was around 60%, and residual lignin content was 24%. And then we control two parameters such as pulp concentration and kneading time. Organocell pulp was diluted in concentration of 5%, 7.5%, and 10% with sodium hydroxide. The diluted pulp was kneaded in Hobart mixer for 1, 2, and 3 hours at room temperature. And then the kneaded pulp was washed with sodium hydroxide and water to remove dissolved lignin. This slide showed how we make film of kneaded pulp. The pulp with different kneading concentration in 3 hours was used. First, the diluted sample was filtered with vacuum-assisted filter funnel. Filtered wet film was dried in gel dryer at 80 degrees Celsius. Basis weight of fabricated film was 60 GSM and average thickness was 100 microns. The prepared kneading pulp and film was analyzed through various methods like presented table. The results and discussion. These slides show the yield and lignin content of kneaded pulp according to the pulp concentration and kneading time. After the kneading process, the pulp yield was reduced up to 10%, and lignin content decreased about 7% due to the alkali treatment. The decrease of lignin content was affected to yield decrease, and also the washing process made a loss that affected to yield decrease. However, the difference of yield and lignin content along to kneading conditions was insignificant. This slide is about sugar analysis. Kneaded fiber had a slightly increase in glucose ratio compared with feed material. Simple mechanical treatment such as kneading does not change it a lot in the chemical composition of the fibers. This slide shows morphology of the organocell pulp and kneaded pulp. This figure is an organocell pulp used as control, and the distribution of fiber length and fiber width shown in the graph. So you can see the particle size distribution on the graph at the bottom left. The x-axis is the fiber width and the y-axis is the fiber length. Control had no fibrillation on the surface of the fiber. When the pulp kneaded at concentration of 5%, the fibers were fibrillated and fiber length and fiber width were reduced. Also, the micronization was more clear when kneaded for 3 hours. This slide shows the pulp kneaded in 7.5 solid. They also micronized, and the fiber size was more decreased with longer time. And at the concentration of 10%, micronization was remarkable, and the fiber size was most reduced when kneaded for 3 hours. To sum up, we did alkali needing to fibrillate the organelle pulp on the left. As a result, fiber fibrillated as shown on the right figure by kneading process. As the pulp concentration increased and the kneading time was longer, fiber fibrillated effectively. So, the fiber length and fiber width were reduced mostly when kneaded for 3 hours at 10% concentration. The results of Kazani fiber analysis showed the same tendency as the result from the optical image. Fiber size under 0.2 mm was defined as fine content, and the average of the fiber length and fiber width over 0.2 mm was shown in the table. The fiber length and fiber width decreased due to the kneading process, and the higher concentration and longer time, the more decreased the fiber size. Also, when the pulp concentration and kneading time increases, the fines contents were higher and the fibrillation effect were improved. This slide shows the effect of kneading treatment on freeness and WRV. The graph on the left shows the freeness of the fiber by kneading time and pulp concentration. Control is shown in black dot, white is 4.5, yellow is 7.5, and red is about 10% of pulp concentration. The higher concentration and the longer time decrease more freeness. The graph on the right is about water retention value. The y-axis is the WRV and the x-axis is kneading time. The kneading treatment increased the WRV of the fiber. The higher concentration and the longer time, the higher WRV. Especially, sample needed for 3 hours at 10% concentration showed the most reduction of freeness and the best water holding capacity. This slide shows the strength of film fabricated with samples needed for 3 hours. The left y-axis of this graph is the tensile index, and the right y-axis is the elongation as shown in the red dot. When the x-axis is the kneading time concentration increased, the tensile index of the film gradually increased, and the elongation also increased. Next, look at the tear index graph on the right. Contrary to the tensile index, the tear index gradually decreased as the pulp concentration increased. The needed sample, which had the best micronization effect, showed the highest tensile index and the lowest tear index. This is because the hydroxyl group of the fiber increased due to micronization and hydrogen bonding was improved, increased the tensile index, tensile strength. This picture supports the data shown in the previous graph, which is the fracture surface of the film after tensile test. When the tensile force was applied to the 5% needed film, not perfect fracture was made. In the case of 7.5% was completely fractured, but a few long fibers were observed between the fracture. Whereas the 10%, the most micronized, showed clear fracture. So it has the highest tear index and it has the highest tensile index. This is my final slide. We carried out an alkali kneading treatment to fibrillate the ligand-rich organelle pulp. And the effect of pulp concentration and kneading time on the micronization of fiber was compared. As a result, the alkali kneading fibrillated fibers well. Also, the higher pulp concentration and longer kneading time made better micronization effect of the fibers. Additionally, the kneading fiber can be applied as a feeding material for nanocellulose, or it could be used for making porous material, as you can see in the movie clip. This was made by myself with kneaded pulp. This study was carried out with the support of project provided by Korean Forest Service. Thank you for your attention.
Okay, thank you. Thank you very much. So it's now open for discussions. So are there any comment or questions from the audience? You can comment using the chat function, or you can directly speak to the presenters. So I have a I have a one question. So please let me see again the fiber morphology of the your material after fibrillation. Maybe you showed some optical microscope images, right?
Yeah.
I'm just wondering if the fibrillated your material still keep the pulp fiber morphology or become nanofiber material. Maybe the right bottom, the right bottom optical microscope images show the highly fibrillated pulp fibers, right?
Yeah.
So, but in the table, the structural profile, maybe you show the table showing the fiber width and fiber length or something like that. But here, yeah, this one. Yes, this one. Now you showed the fiber width decreased from the 31.18 to 27.97, right?
Yeah.
Fiber width, right? Yes, yeah, this one. So, but in the previous photographs you showed now, show no, but these images show much more drastic changes in the pulp fiber morphologies.
Yeah.
Why your number show just a slight change in the fiber width, just from the 30 to the 27 or something like that, very slight change in the number. But your optical microscope images show the very drastic change. I'm just confusing.
It was average of particle that was micronized or not. Big particle that was not shown in the image
Okay.
was contained in the Kazani fiber analysis.
Okay, you mean the even the nanofibrillated materials obtained at concentration 10%, and the kneading time for the 3 hours still include very big fibers, right?
Yes.
Okay. Okay, I got it. Okay, We still have the 1 minute or something. We can have a very short question still. Are there any questions? No? Okay, thank you again, Mr. Salan Choi.
Thank you.
Thank you very much. So the next talk will start 25. So that's why please wait a bit. We will start next presentation at the 1:25.そうです、そうです。じゃあちょっと待っててくださいね。 Okay, time is coming. Let me introduce the next speaker. The next speaker is the Mr. Ryota Inoue. He's from the Tokyo University of Agriculture and Technology. He's working with Professor Kose. He's going to talk about the effect of simultaneous increase in base weight and beating degree on basic properties of the papers. So please start your presentation when you are ready.
Okay, thank you for Professor Saito. I'm Ryota Inoue from Tokyo University of Agriculture and Technology in Japan. The title of my presentation is Effect of Simultaneous Increase in Base Weight and Beating Degree on Basic Properties of Paper. Firstly, I'd like to introduce new high-volume applications for paper. Recently, with the implementation of electronic information technologies, the demand for printing paper has decreased significantly. So, new high-volume applications for paper are required. For example, electronic device casing, robot bodies, and skeletal materials. Please look at the picture on the right. This robot arm is an example of applications of paper I would like to develop. The development of high-strength paper will be key to meeting the physical requirements of these new applications. So we need to find ways to improve the paper strength for these applications. Here, to increase the paper strength, we have chosen two methods, high base weight and high beating degree. In addition, the multi-layer method was used to increase the base weight. I'd like to introduce now the previous knowledge on our research. As this figure shows, numerous studies on the properties of paper with high base weight or high beating degree have been reported. However, no published reports have presented a systematic study by combining the two variables. In this study, we prepared handsheets that combine both high base weight and high beating degree. And we studied the effect of multi-layering them. In this presentation, we will call paper what should be called a paperboard. Based on this previous knowledge, we conducted this study for two purposes. The first purpose is about single-layered paper. We want to verify the combined effect of the increase the base weight and the beating degree value on the basic properties. Here, we evaluate the paper strength with the tensile test. The second purpose of this work is to acquire basic knowledge to improve paper strength for structural applications of multi-layered paper. Here, we evaluated the paper strength with bending tests. I'd like to move on to the explanation of materials and the methods. First of all, let me talk about single-layered paper. We use dry pulp made from fully bleached softwood craft grade as the raw materials. We used the craft pulp was beaten into disintegrated pulp using a Niagara beater. Samples are taken when the freeness reached 365, 136, and 66 milliliter CSF. Here, the freeness was modified according to standard from that in the abstract. The lower the value, the higher the beating degree. We prepared 9 handsheets from the 3 pulp samples at target base weight of 16, 120, and 240 grams per square meters. The handsheets were air dried at 23 degrees. We prepared these 9 types of handsheets. Here, I'd like to explain about measuring the basic properties and the tensile test. First, we cut the handsheet into 140 millimeters by 45 millimeters test pieces. We measured thickness and quality, and then calculate the apparent density and base weight. The 6 white star mark is the thickness was measured. Next, we cut the test pieces into 140 millimeters by 15 millimeters test pieces. We measured thickness and calculate the cross-sectional area. The 3 black star mark is the thickness was measured. We performed a tensile test using these test pieces. The tensile test gave breaking load and break aggression values. We calculate the tensile strength, tensile stress, tensile elastic modulus, specific tensile energy absorption from those values. In this presentation, for the sake of time, I'll talk only about the density, tensile strength, and tensile stress measurement results. Next, I'd like to talk about the multi-layered paper. Similar to single-layered paper, we prepared hand sheets at target base weight of 215 grams per square meters. The freeness was 405, 214, and 385 milliliters CSF. We multi-layered this hand sheet in 8 layers to 2,000 grams per square meters for the 405 milliliters CSF and 214 milliliters CSF. In the same way, we multi-layered the sheets in 12 layers to 3,000 grams per square meters for the 405 milliliters CSF and 16 layers to 4,000 grams per square meters for the 385 milliliters CSF. We dried the multi-layered paper by using hot press at 105 degrees. We obtained 4 types of multi-layered paper. Now let me explain about measuring the basic properties and the bending test. We cut the multi-layered paper into 120 millimeters by 5 millimeters test pieces. We measured thickness and quality and then calculate the cross-section area, appearance density, and base weight. The 3 black mark is the thickness was measured. We performed a bending test using these test pieces. The bending test gave bending strength and the bending strain. We calculate the bending stress and the fracture modulus from those values. For the sake of time, I'll talk only about the density and the bending stress measurement results. I'd like to move on to the result and discussion. This figure shows the relationship between the density and the base weight of the single-layered paper prepared with different freeness values. There is a positive correlation between the density and the base weight. As you know, with the same base weight, the density increases as the beating degree increases. The important point here is that density can be maximized using a combination of high base weight and high beating degree. Therefore, it is expected that the tensile stress wherein the tensile breaking load is corrected by the cross-sectional area will increase. This figure shows the relationship between the tensile strength and the base weight of single-layered paper prepared with different freeness values. There is a positive correlation between the tensile strength and the base weight. As you know, in high base weight region, the tensile strength increases as the beating degree increases. What is interesting here is that the slope of the approximated straight line for the 66 milliliter CSF hand sheets was approximately 1.6 times greater than that of the 365 milliliter CSF hand sheets. The tensile strength is efficiently increased by the combination of high base weight and high beating degree. This figure shows the relationship between the tensile stress and the base weight of single-layered paper prepared with different freeness values. The 365 milliliter CSF hand sheet showed a negative correlation. However, I'd like to stress that as the refining progressed, the 136 and 66 milliliter CSF hand sheets did not exhibit a clear decreasing tendency. In particular, in the high base weight region, the 66 milliliter CSF hand sheets showed higher tensile stress than other freeness values. In this slide, I'd like to discuss why the tensile strength is efficiently increased by the combination of high base weight and high beating degree. First, I consider the case where the beating degree is increased with low base weight. Fibers larger than the wire mesh make up wet web. So fines go through the wire mesh and fall off. On the other hand, I consider the case where the beating degree is increased with high base weight. Because we use a lot of pulp to make hand sheets, fines get caught in wet web formed earlier. So these fines may improve the paper strength. This can explain why the slope of approximated straight line of the tensile strength increased. Now, I'd like to move on to the topic of multi-layered paper. This figure shows the relationship between the density and the base weight of multi-layered paper. The red point indicates high beating degree. There is a positive correlation between the density and the base weight at the freeness of about 400 milliliters CSF. The red point shows that the density can be maximized using a combination of high base weight and a high beating degree. You can notice that it shows the same tendency as the single-layered paper. Therefore, it can be expected that the red point in further high base weight region also will show a positive correlation. This figure shows the relationship between the bending stress and the base weight of multi-layered paper. The red point indicates high beating degree. This point shows that bending stress can be maximized using a combination of high base weight and high beating degree. The about 400 milliliters CSF multi-layered paper did not exhibit the clear decreasing tendency. You can notice that it shows a different tendency from the single-layered paper. It can be expected that the red point in further high base weight region also will not show a clear decreasing tendency or will show a positive correlation. In this slide, I'd like to talk about the comparison of strengths between multi-layered paper and aluminum for the new high volume applications from paper. We compared the strengths of the two materials by bending stiffness. Bending stiffness is calculated by multiplying the flexural modulus by the cube of the thickness and dividing by 12. Using this formula, the bending stiffness of 2 mm thickness aluminum is 47.3 Newton meters. We have set this value as a numerical goal. On the other hand, the multi-layered paper with the freeness value of 385 milliliters CSF and target base weight of 4,000 gram per square meters has thickness of 3.85 millimeters and flexural modulus of 5.33 gigapascal. So bending stiffness of multi-layered paper is 25.3 Newton meters. The bending stiffness of the multi-layered paper approaches that of aluminum only by increasing the base weight. Therefore, the bending stiffness may be further improved by simultaneously increasing the beating degree. I'd like to summarize the main findings of this study. We have three conclusions regarding single-layered paper. First, the maximum density was obtained through a combination of high base weight and high beating degree. Second, the slope of the line that represents the relationship between tensile strength and base weight at the freeness of 66 milliliters CSF was approximately 1.6 times greater than that for 365 milliliters CSF. This suggests that the tensile strength is efficiently increased through a combination of high base weight and high beating degree. Third, the tensile stress with high base weight and high beating degree did not show a decreasing tendency. We have two conclusions regarding the multi-layered paper. Firstly, the density shows the same tendency as the single-layered paper. Second, the bending stress with only high base weight did not show a clear decreasing tendency. This is different tendency from that of the single-layered paper. Thank you very much for your attention.
Okay, thank you. Thank you very much. Are there any questions or comment from the audience? When you have questions, you can write your comment in the chat box, or you can also directly speak to the speaker. Okay, from the mentioned Zhao, thank you. Moment, please. So I'm asking you instead of the audience that how did you prepare multi-layered paper? Only stacking dry sheet or then pressing at 105 degrees Celsius? No re-wetting. Please answer to this question.
Okay. Okay. Multi-layer method is this. First, after coating wet paper, the watering press multi-layered, and after the watering press, we use hot press at 105 degrees. Is that okay?
Okay, maybe okay. And no re-wetting. How about the re-wetting property of the multi-layered board? What happens when you drop just for example you water drop? What happens when you just soak your board material into water? Water drop or just soak your board material into water? What happens?
Water drop is here and here. Oh, okay. I didn't catch your question.
Okay. So he's asking, and the audience, one of the audience is now asking, no re-wetting? Is there, what happens when you wet your board material after drying?
After drying, wet.
So re-wet.
Re-wet.
Re-wet. It become. The audience is now asking the hydrophilic properties of your material, board material.
Oh,
is it?
Oh, is it? Oh.
Maybe you didn't add any AKD treatment or hydrophobic treatment
Okay. No. Yeah.
No, that's
only
why
only use pulp.
That's why maybe your board material can absorb water again, right?
Okay, I didn't try this.
Okay.
Yeah.
Okay.
Thank you very much.
Are there any questions or comments? No. So I have a question. We got a question. Okay, I'm asking you instead of the audience. According to the presentation, multi-layered sheet was prepared under hot press. So I wonder if there is any trouble with vapor pressure during hot pressing.
Oh, okay. And trouble. So vapor pressure. Sorry. Triangle. Sorry. Okay. I'm sorry, but it's not possible to give that information yet.
Maybe this audience is now wondering when you hot press the wet sheet, water evaporate when you hot press, right?
Okay. It's right.
Yeah. Then maybe when you prepare multi-layered hand sheet, about wet hand sheet, then when you compress with high temperature, maybe the water evaporate quickly. A lot amount of the water evaporate quickly at very high temperature.
Then 105 than 105. We tried several temperature. This temperature is so suitable.
Okay, the audience giving us some their answers or their considerations. The towel handle it. I got it. I also think that you sandwich your material with the Kim towel. Maybe that give the pathway for the evaporated waters.
Pathway.
Okay. Again, we got the questions. It's very heavy seat. Your multi-layered seat. It's very heavy seat. That's why you should usually get some trouble in the dead lamination problem caused by the vapor pressure. Maybe the no dead lamination problem when you give hot pressing onto your multi-layered wet seat. No, okay.
Yeah.
Maybe the hand seat or the sandwich structure handle it. Okay, thank you. My time is already past. Thank you again. Okay, the next presentation will start from the 1:50. That's why 3 minutes later we are 3 minutes later we will start again. That's why please wait a bit. The next speaker is Ji-Hong Lee. Are you there? Okay, please share.
Hello.
Hello, please share your screen. Okay, time is coming. The next speaker is Mr. Ji-Hong Lee from the Seoul National University. He's working with Professor Hagwell Lee. Then he's going to talk about the new method to qualify morphological structure of latex binder in pigment coating layers. So please start your presentation when you are ready.
Good afternoon, everyone. I'm Ji-Hong Lee from Seoul National University. Today, I'm here to introduce a new method to quantify the morphological structure of latex binder in pigment coating layer. So, as you know, the synthetic latexes are widely used in a variety of applications, such as paint or paper coating and other waterborne adhesives and coatings. These pigmented latex coatings are, the structure would be quite different depending on the latex content. If you have a high latex content, like paint, then the latex binder makes a continuous film and the pigments are inside of the film. However, when the latex content is low, example, paper coating, the voids are introduced into the structure and the latex film doesn't become continuous anymore. So in case of high latex content coating, the interaction between constituents of the coating layer determines the properties of the coating layer. However, in case of low latex content coating, the ordering and addition of latex particles to pigment particles and substrates becomes very important in determining the properties of the coating layer. Therefore, the subject has been researched for decades in paper industry and mostly focused on the distribution of binder, especially to investigate the effect of binder migration because of its high influence on printability or the mechanical property of coating layer. So various techniques have been developed and applied, like surface analysis or a distribution of binder in thickness direction. The spreading and wetting behavior of latex particles also plays a decisive role in structure formation and properties of coating layer. Therefore, the spreading of an individual latex particle using model studies was often utilized to present it. And also some studies in old days used the qualitative observation using the electron microscope images to depict it. However, none of the studies have actually quantified it within the coating layer. So the main objective of this study is to quantify the morphological characteristic, I mean the addition and the spreading of latex binder in the pigment coating structure. So for this, we propose some novel concepts to numerically present the deformation and addition characteristics of latex binder in paper coating layer. And this was presented using cross-section image analysis. So the developed techniques are applied to some case studies to verify it, so which is comprised of the coating layers composed of different TG latexes and coating layers formed in different drying temperature or treated with different heating condition. For the coating color preparation, the coating color was only comprised of just pigment and binders. For pigments, fine GCC for top coating was used, and binder, SB latex binder with different TG, but similar particle size and gel content was used. And target solid content was 62%, and pH was controlled to 9.5. The addition level of SB latex was 12 part per 100. And the coating layers were prepared on the corona-treated PET film, and coat weight was 10.8. And drying condition, drying and heating process were drying and heating processes were proceeded in the hot air drying oven, and the temperature was different. All prepared coating layers were conditioned in 25 degrees Celsius, 50% relative humidity for 24 hours. So summarizing the samples, so first case study is latex binder with different TG. So all coating layers were dried in 25 degrees and different TG latexes were used. And second case, the highest TG latex was used and the drying temperature was different. In third case, the highest coating, also the highest TG latex was used for the coating layer, and it is dried in 25 degrees Celsius. And after drying, the coating layers were treated with heat 25 and 60 and 120 degrees Celsius. For cross-section imaging, FIV FESAM was utilized, and the coating layers were also osmium tetroxide stained and embedded in epoxy resin. And FIV milling process was proceeded in two stages. First is the coarse milling, and second with fine milling. Both SE and ESD mode images were used, and at least 10 pairs of images per condition were used for the analysis. So introducing the first concept is the named surface area index, which is abbreviated in SA index. It is derived from the idea that if latex shows better dispersion and more deformation within the coating layer, then more surface area would be created with same dosage of latex binder. If you put this situation into 2D cross-sectional image, the surface area would be correspond to perimeter of binder, and the dosage, which equals to volume, would be the area of binder. So the calculation of the SA index would be the square of perimeter of binder, and that is divided by area of binder. The constant K is just for legibility. And this is the image processing procedure on how to calculate the SA index. So from the segmented binder images, you can get area binder, and you can also get edges here, and this can be used as perimeter of binder, so easily can be calculated. The segmentation process here, it is based on our previously developed method for FIV. The main feature of this method is the selective blurring technique, which preserves edges very well and small holes during noise reduction. And second main feature is the locally adaptive thresholding, which minimizes the effect of background contrast. So further information you can find in this publication here. So if you look at the result, these are the actual part of actual coating layer images, and this one shows the result of the SA index. And you can see that as the TG elevates, TG of latex elevates, the latex particle maintains its provisional sphere shape, which is not creating so much surface area on it. And you can see that the result is decreasing. So it actually successfully presenting numerically the dispersion and the deformability of latex within coating layer. And second case also shows that the changes of the latex binder depending on the higher drying temperature. So as the drying temperature elevates, the structure becomes like more spreaded and connected channel-like structure. And also you can see that it is numerically presented with the proposed index. And third case is also similar, but the change becomes smaller because it is not treated in wet state coating color. And introducing the second concept is named as addition area index, which is also abbreviated in AA index. This is an index presenting the amount of actual addition area of binder to pigment particles created with same dosage of latex binder. So if you also put this into the cross-section image, 2D image situation, the addition area of binder would correspond to the length of pigment binder interfaces, and the dosage would be the area of binder. So if you calculate this index, the calculation is that the square of the length of pigment binder interfaces divided by the area of binder. Also, the K is just for the legibility of the index. In case of the pigment binder interfaces, it is quite difficult to get image segmentation because this is the weak edge in the coating layer. So this shows the principle of how we segmented these pigment binder interfaces. So if you can see that these pigment binder interfaces are depicted as the red lines in here, and other things, the pigment pore is to blue edges, and the binder pore edges are depicted in the green. So if you think of the perimeter binder, it consists of the pigment binder interfaces and binder pore interfaces. And the perimeter of pore is composed of the pigment pore interfaces and binder pore interfaces. So if you subtract these two things, then the binder pore interfaces are disappeared because this is overlay, and the binary image actually cannot get the negative value. So these pigment pore interfaces would be also the zero value in the binary image. So the only left one is the pigment binder interfaces here. So this is, you can see the actually how we did on the image processing procedure. So we get the edges of binder, and we get the pore here, and we actually don't need to make it edges, just dilate it to get better overlaying of the interfaces. And if you subtract it, then you can get these pigment binder interfaces. So this here you can see that overlay image of the segmented pigment binder interfaces on the actual coating layer, and you can see that it's quite well fitted to the image. And also the addition of surface of baseline, this is included because we should exclude the interface between binder and substrate, and also the binder and the air. So the second processing procedure can be summarized like this. And as you've seen in former page, the pigment binder interfaces are segmented, and also the area of binder can be derived from the segmentation of binder. So the AA index is also easily calculated with this method. And the segmentation process of pore is also based on our previously developed method. So this is the result of the second concept. So you can see that TG makes quite different in contact with the surface coverage of pigment particles with binder. And you can see that as the TG elevates, the index becomes lower. The index is quite well showing numerically the addition properties of latex inside the coating layer. And also this is the case of the drying temperature, and is changing also numerically. And you also can see third case, also the index is applied well, presenting the addition property of latex. So finally concluded, so we developed a novel concept, two novel concepts to describe the spreading and adhesion behavior of latex binder within coating layer. And the image processing and analysis methods were developed to quantify the concepts using FIV FESEM cross-section images. And the case studies were applied and have proven that the developed concepts well explain the structural changes within coating layer. So this study was supported by LG Chem and NRF in Korea. Thank you for listening to my presentation, and please ask any questions. Thank you.
Thank you. Interesting. Okay, it's now open for discussion. Are there any questions or comment to this presentation? Or also you can, of course, directly speak to him. Okay, from me. So it's very interesting. My well planned, and also that you discovered very good findings. I also think that image processing is now becoming a very hot topic in the science. The image include a lot of information. That's why the automated approach is very important. That's why I am very impressed with your work. So I'm not familiar with the programming. So you programmed by yourself for this work.
For the processing algorithms, they are usually existing algorithms or developed in other areas, like such as.
Okay.
But if I want to apply it into paper coating layer, I should modify it a bit, and also I should combine some different algorithms or methods together to make one process for the layer. So in that case, I need to codify by myself using. I use the MATLAB.
MATLAB.
Yeah.
Okay. Interesting. Okay. Indeed, I was just convinced with your presentation. That's why I have no good questions to you. Are there any questions or comments to him? Maybe your new program can be applied to other image processing material, right? Do you have any ideas of the potential structure which can be analyzed by your new program?
This is actually focused on the low latex content coatings because I really wanted to quantify the morphological kind of changes. It's actually usually depicted in some articles, like just showing qualitatively, and this one is changed or shrink more than other coating layers like that. But I really wanted to numerically present it. So I think these methods can be applicable to any kinds of low latex content coating, which can show different coating constituents with different color in the image. So, actually, I'm kind of applicating this to other coating layers received from some like other engineering departments, or these days also on some specialty papers too. So.
Good. Thank you. Okay, my time is coming. If you don't have any questions to him, we can upload to him again. Thank you.
Thank you.
Okay, the next presentation will start at the 14:15. That's why please wait for 5 minutes. Okay, sorry, the time is coming. The last speaker is the Kiev Kim Nanara from the Tsukuba University. He's working with Professor Enomai. He's going to talk about a study of paper-based sensor with assistance of paper-based heater for detection of residual pesticides. Sorry, I don't know, through color change. Please start your presentation when you are ready.
Okay, can you hear me, everyone?
Yes.
Okay. So, good afternoon, everyone. My name is Kim Nanara, and now I am a master candidate at the University of Tsukuba under the supervision of Professor Tatsuharu Enoma. And the topic today that I'm going to present is a study of paper-based sensor with assistance of paper-based heater for the detection of residual pesticide through color change. And then let's go to the, sorry. This is the outline that I'm going to explain today. And the first one is introduction. And in the introduction part, I will explain to you about the influence of residual chemicals and principle of detection. Number 2 is validation test of esterase reaction with inoxidil acetate. And then in this part, I will explain to you about the enzyme extraction method, color change reaction results. Number 3 is improvement of the sensing speed by built-in heater. And then I will explain to you about the CNT heater fabrication, power supply method, and then result. And number 4 is application of pesticide detection. And final one is conclusion. Now let's go to the introduction. As you know, in agricultural sector, many toxic chemicals have been applied in order to improve the crop yields of agricultural products such as fruit, crops, vegetables, and so on. And although they provide some advantages in agricultural sector, however, the remain toxic chemicals in these agricultural products can cause to have many health problems. And based on the chemical structure or chemical compound, they are divided into 4 main groups. And the first one is organophosphate, so all we can call OP. And then in OP group, we have so many pesticides, and most of them are insecticides. For example, is dimethoate, malathion, methamphetamine, ammoxate, and so on. And number 2 is carbamate, or we can call CM. And then in this group, we have many pesticides such as adicarb, carbofuran, carbaryl, methomyl, and so on. And number 3 is organochlorides, or we can call OCs. And the last one is pyretrins. However, among these toxic chemicals, OP and CM were commonly used, and they are very toxic to human health. Based on the previous study, especially with the study of Kenan in 2007 and Gandhi in 2015, they have found that inoxidil acetate, which is kind of dye, and then it can be hydrolyzed by some enzymes such as acetylcholinesterase or esterase. And the final production from this enzymatic reaction is indigo, which is kind of blue crystals that we can see and observe by our naked eyes. And however, in a presence of pesticide, the color density of indigo blue can be decreased or sometimes disappear. Depends on the concentration of pesticide that we use, how much that we use. So based on this mechanism, pesticide detection method based on enzyme inhibition method has been developed. And you know, there are many kinds of analytical techniques, but one of the most popular for analysis is paper-based sensor, because paper-based sensor is low cost, eco-friendly, biodegradable, recyclable, and usually rapid response. So because of this, in my study, I have 2 main objectives. And the first one is to fabricate a simple paper-based sensor for pesticide detection based on enzyme inhibition method. And the second one is to improve the function of paper-based sensor by building a temperature controllable system. Next slide. Experiment 1. So in this part, I will explain to you about the validation test of esterase reaction with inoxidil acetate. And then I will explain to you about the enzyme extraction method here. So a measured amount of wheat flour has been prepared and dissolved in deionized water, and it was stand for overnight at 4 degrees Celsius. And then the solution has been filtered, and then the filtrate has been centrifuged for 5,000 or per 10 minutes. And then the supernatant has been collected, and then I add ammonium sulfate to get 30% of saturation, and then it was stand for overnight at 4 degrees Celsius. And after that, it was centrifuged again at the same speed at 5,000 or per 10 minutes. And after that, I add ammonium sulfate again to get 60% of saturation. And then it was centrifuged again at the same speed for 10 minutes. And after that, the sediment that contain enzyme has been dialyzed in phosphate buffer at pH 7. And then it was stand for overnight at 4 degrees Celsius. And after that, the purify enzyme has been stored at minus 20 degrees Celsius in the refrigerator before using. So here, I will explain to you about how I fabricate a simple paper-based sensor and then how I apply the enzymatic reaction. And the first, a filter paper has been cut into 6 by 6 millimeter, and then it was fixed to the photo paper by using a adhesive tape. Here like this. This is the filter paper. And after that, I apply the enzymatic reaction by mixing 5 microliter of phosphate buffer and then 2.5 microliter of esterase. And then it was mixed with 5 microliter of ethoxyl acetate. And then the final solution has been spotted on the test zone of the paper-based sensor. And after the enzymatic reaction happened, the color will change from colorless to greenish blue, and then from greenish blue to blue like this. And after that, colorimeter was used to evaluate the color changes. So colorimeter is very important for quantitative analysis beside our eye observation. Result and discussion. So in this part, I will explain to you about the color changes at different temperature. So first, at room temperature, we can see that the color change from colorless to greenish blue and then from greenish blue to blue. And this is, it means that the reaction happened by, ethoxyl acetate has been hydrolyzed by esterase and then it converted to indigo blue like this. However, I feel the reaction happen at room temperature is not so fast. So I also observe in higher temperature. And then I got the result like this. So at 35 and 40 degrees Celsius, we can see that the color change to greenish blue seems to be more faster than room temperature. But it might be somehow difficult to judge the color changes between 35 and 40 degrees Celsius. And so I also use the colorimeter to evaluate the color changes based on LAB color system. And then from the result, we can see that LA color value decrease and subsequently increase while B value level off. And B values represent at room temperature while green and red represent the color changes at higher temperature. And from the graphic, you can see that the red was higher for the heated samples compared to the unheated samples. And then because I already explained that the final production from this enzymatic reaction is indigo blue, so B value was a suitable parameter for analysis the coloring process of the esterase reaction. But we still can see some changes of the LA color trends because
Oh, he stopped. 江前先生、
はい。
なんか落ちちゃったみたいですね。
ちょっと様子見てきます。近くにいるんで。
はい。Okay, please wait.
Nana-kun, can you hear me?
Yes, I can hear you. So what should I do now? So do I
Okay,
have?
restart. Yes.
Nana-kun,
Yes, I hear you. So do I have to continue or
Yeah, please continue your presentation.
okay? So
Uh,
okay, so because of this, I came up with a new idea to fabricate a heating system for accelerating the enzyme reaction. So the first carbon nanotube has been spotted on the photo paper, and then it was dry. And then when it dry on the backside of the CNT heater, I fixed with the filter paper, which is designed as a test zone. And after that, it was connected to a power supply to generate heat by applying different voltage. Okay, next slide. Material and method. So in order to measure the thickness of CNT layer, the thickness gauge was used to measure the thickness, and then I used resistivity method to measure the resistance of the CNT heater. And after that, power supply was used a main material to generate heat. And after that, temperature logger was used to measure the temperature changes or the temperature increase. So this is the result of the improvement of the sensing speed by built-in heating system. So this is the result of electric property of the CNT heater. And then from the result, we can see that the resistance decreased dramatically when we increase the thickness of CNT layer. And then, so we can say that higher thickness of CNT, lower resistance of CNT produced. And however, for the specific material design, the resistance of CNT layer is around 3 ohm. And moreover, it is also important to find the optimum thickness of CNT layer for propagating the heating system. This is the result of a thermal property of paper-based heater utilizing power supply. So for the first one is I coated with a 0.0 and 22 millimeter of CNT thickness. And then the temperature is around 28 degrees Celsius when we apply a 3 volt. And then it can reach to around 32 to 30 when I apply 4 volt. And then it can reach to around 40 degrees Celsius when we apply 6 volt. And not different from the previous one at 0.0 and 41 millimeter of CNT thickness, the temperature is around 29 degrees Celsius when we apply 3 volt, and then it can further increase to around 35 degrees Celsius when we apply 4 volt, and then it can be increased more to around 40 when we apply 5 volt, and then it can be reached to around 48 degrees Celsius when we apply 6 volt. And then for the 0.0 and 71 millimeter, we can increase the temperature more to around 32 degrees Celsius when we apply 3 volt. And then it can be reached to around 50 when we apply 6 volt. And then for the highest thickness of CNT layer, in my study, I coated with a 0.0 and 96 millimeter of CNT thickness. And then I found that the temperature can be increased more to around 33 degrees Celsius when I apply 3 volt. Then it reached to until almost 60 degrees Celsius when I apply 6 volt. So this is the I just summarized the result from the previous slide. And based on the study of Wang in 2012, they have found that at 35 degrees Celsius, the esterase reaction occur most actively. So from the result, we can say that at higher voltage and higher thickness, we can get the temperature 35 degrees Celsius more rapidly. Next slide. So for this slide, I apply the application for pesticide detection. So in order to apply my system for pesticide detection, first the mixed solution of 2.5 microliter of esterase and 5 microliter of pesticide has been incubated for 20 minutes. And then after that, it was mixed with 5 microliter of inoxyl acetate. And then the solution has been spotted on the test zone here. And then it was I applied the heating system like this. And after that, a colorimeter was used to measure the color changes after the enzymatic reaction happen. Results. So in my study, I apply molybdenum as one model pesticide, and molybdenum is a member of OP pesticide group. So from the result, we can see that the color density of indigo blue decreased dramatically when we increase the concentration of pesticide from low to high. So in my study, I applied from 3 ppm until 50. And then not only the color density based on the image, but based on the B value, you can see that the B value is increased when we increase the concentration of pesticide. For example, at the 0 ppm, it means that without a pesticide, the B value is just around minus 11.80, and then it's reached to around minus 3 when we apply with 50 ppm of pesticide. So it means that the higher concentration of molybdenum, the lower color density of the form indigo produced. And then in my study, I come up with the conclusions like this. So in this study, for the first time, a paper-based CNT heater was applied as a temperature controllable system for accelerating the enzymatic reaction on paper-based pesticide sensor. And after that, the application is not so laborious, and it just needs only coating the CNT ink on a photo paper and then connect it to a power supply to generate heat for the enzymatic reaction of the paper-based sensor. And then molybdenum has been detected by the system from 3 to 50 ppm. And then the final conclusion is the paper-based sensor combined with the paper-based heater provides an alternative tool for the convenient detecting of residual pesticide with the minimized reagent consumption and a simple operation by non-trained personnel. And thank you for your kind attention, and then thank for your listening.
Thank you. Thank you for your good presentation. We've already got a question from Professor Hakulai Lee. Maybe Professor, maybe you can directly ask to him. Maybe it's much more efficient for you to.
Oh, okay.
Please.
Oh, nice work. It is very interesting.
Yes.
And to use such an instrument to detect pesticides, I think it is quite important to have very low detection levels.
Yes.
I'm just wondering, what is your detection level? What is the detection level of your method? What is the minimum concentration of the pesticide you can detect?
Actually, in my study, I mainly focus on the heating system for accelerating the enzymatic reaction, and
Okay.
and then I also apply with the commercial enzyme nowadays. And then for the molybdenum, the detecting, I mean the level of molybdenum in that they allow to use in the fruit or in agricultural product is around 2 ppm.
Oh, okay.
And then in my study, I also apply with a commercial enzyme, and then I found that I can detect the molybdenum around 1.5 ppm. But but in this slide, I produce a new method by enzyme extraction from plant. But I mainly focus on heating system.
Oh, okay. Thank you. Thank you.
Okay, thank you very much. Time is coming. That's why thank you. The Kiev. Good presentation. And thank you for we got another question. Maybe the from now we have a break. That's why maybe you can answer to him. Thank you for your interesting topic to share with us. You use color meter to measure the color.
Yes.
Could we use any other software to measure color density like ImageJ instead of color meter?
Actually, I saw many papers. I saw many journal article papers. Most of them they use ImageJ and other color software. I also try, but I think that it is somehow difficult to control the situation. For example, if you want to measure the color changes of the reaction, you have to do it in the same day. If you do in other days, it might be difficult. And then every time that you capture the image should be the same. So if you use the colorimeter, it might be more easier.
Okay, good. Thank you for your good presentation. Okay, so from now on we have a break. The all scheduled presentation in this session have finished. So please come back here, the 2:55 in Japan time. Okay, see you then.大石先生お疲れ様でした。僕またこの後はオーディエンスで残って聞いてます。
はい、どうもご苦労様。
お疲れ様でした。
大石先生、お世話になります。市民総研池田です。
はい。
進め方ですけれども、今みたいに時間通りに15分発表、5分質疑応答で。
15分発表、5分質問で。
インターバル5分、もし早く終わったらインターバル5分を空けるぐらいでいいですかね。よろしいですかね。
早く終わったときは何？
早く終わったというか、今、斉藤先生の時の大体各発表間に、4分、5分ぐらいインターバルがありましたけれども。はい、わかりました。はい。
インターバルは守って、
はい。
初めの開始時間を守るようにしてください。
はい、わかりました。
それから、このズームの座長はなかなか大変だと思うんです。質問者をね。
はい。
見つけるのがなかなか。
はい。私も授業とかで使っておりませんので、全然操作を慣れておりません。
チャットっていうところがわかります？
はい、わかります。
そこをちょっとクリックしてチャットを開いてくれませんか？
はい。
で開くとそこでですね、そこのチャットの中に質問を入れてもらうようにしてるんですよ。
はい。
皆さん手を挙げてくださいって言っても手を挙げない人も多いし、
はい。
それでそのチャットの中に書いてあって、その質問者が池田さんがよくわからない人だったら、
はい。
池田さんが代わりに読んで、
はい。そうですね。はい。わかりました。
で、わかる人だったら、どうぞ先生、自身から説明して
はい。わかりま
くださいっていうふうに言ってもいいんですけど。
はい。よ
ろしくお願いします。このインターネットはこうやってずっと座ってるので、やっぱ体をね、体操するみたいに動かさなきゃいけないんですよね。
そうですね。
エコノミー症候群になっちゃうんですよ。
はい。
ね。はい。消してですね、体操しますので。1、2って体操する。
あ、池田さん。
お世話になります。池田です。
宮西です。
はい。
聞こえるでしょうか。
聞こえております。私の声も聞こえておりますでしょうか。
はい、もう、はっきり聞こえてます。
ありがとうございます。今日よろしくお願いします。
よろしくお願いします。